All right, all set. 363 days ago, we were right here at Build, announcing publicly Semantic Kernel to the world. A lot has changed with AI in the last year, but a lot stayed the same. Semantic Kernel is still open source and MIT licensed. Our mission to empower every app dev to increase productivity and exceptional service remains the same. We started our journey with .NET, and the response has been amazing. 1.1 million downloads of the .NET kernel since we launched. And late last year, we released .NET to the world with 1.0 .NET. And we've also spent a lot of time listening to you, our community, and really learning along the way. With your feedback, we ensured the enterprise components you needed to go to production were available. You can deploy Semantic Kernel at enterprise scale with security, monitoring, and compliance hooks ready to go for you to use today. Our listening tour included things like our office hours that we still host via Teams every week, one-on-ones with you, and also on-site visits to really see how does AI really work at enterprise scale. And we saw something. We saw a divide. We saw that AI development includes more than just AI developers. It includes AI researchers who are pushing the envelope of what AI means today. To support that entire life cycle, though, AI developers need an easy way to take their POCs, right, and transition those over to their app dev counterparts, whose day-to-day includes things like supporting lifesite, right, monitoring and deploying to production. AI libraries today don't allow this transition between these two teams. And because of this, there's a huge chasm, right, between these two teams to be able to really deliver AI value to enterprises. Until today, we've spent the last 6 months closing this chasm on the AI and app developers, having a seamless development experience that brings them together and leverages the best skills from both teams. So let's bring Matthew out to the stage so we can see what's possible today.
Awesome. Well, thank you, Evan, for sharing why we are so passionate about bridging this divide, this chasm between AI researchers and app developers. Because I fundamentally believe that it shouldn't be that way. There shouldn't be this divide. In fact, they should be working hand to hand as one team. Because together they can best use their own capabilities. AI researchers are looking into the future, trying out the latest models, the latest strategies. Enterprise app developers keep the lights on. They build performant, secure, reliable services that create customer trust. These are two different skills that work together. But they don't work together today because of the tools they use. So AI researchers are predominantly Python. Your app developers are using .NET and Java. And so the Python devs, once they get to the point where they're releasing an application, like, oh, shoot, I have to do LiveSite. I've never done that before. Enterprise app developers, you're on the sideline. You don't know how to do all this AI stuff as well as some of your counterparts. So there needs to be a bridge. We don't want you to have to learn a whole new set of skills in order to become enterprise app developers or to learn the latest cool AI stuff in Python. We want you to work together and have a bridge so that y'all can talk to each other, collaborate. Right? And that bridge in Microsoft is Semantic Kernel. And this week is really exciting, not just because of Build, because today we are announcing, we have 2 blog posts out, the V1 versions of both Python and Java. That means all of our SDKs, Python, .NET, Java, are all V1 plus. Now, concretely, 1, that means we're not breaking you. I don't know any other AI SDK that is committed to V1 and not breaking folks. That means you can build something today, a year, 2 years, you're not going to have to do a refactor, right? 2, if you do use us across your different teams, you can align on concepts. We figure out what is an agent. We figure out what is a plugin. So y'all don't have to have those semantic arguments, right? You can focus on building things for your customers. And then the last one, going back to that bridge metaphor, we made sure that for each of our V1s, they had the same inputs and had the same outputs. So if you have a prompt, if you have a plugin, and use any of these, they'll work the same. That's huge because your AI developers can do what they do best. Build POCs, figure out what's coming next, make sure your company sells relevant, and once it's ready to go to production, they don't have to figure out DevOps, and they're not angering their enterprise devs asking them to refactor and rebuild everything from scratch. They're just passing over assets. So to show you just how easy it is to go from Python to .NET, I'd like to invite John Maeda onto the stage, and we're going to have a special Mr. Maeda's Cozy AI Kitchen on stage today.
Hello, everyone. Honored to be here because my function has been to help more people understand AI and be less scared about it. You may know the famous Semantic Kernel toaster on Mr. Maeda's Cozy AI Kitchen. You may know that the GPT-4 model has been upgraded. Notice the eyeballs. And also we have the jumbo jar of personas to represent the agent era, embeddings, etc. But in the process of really creating more AI chefs out there, I am humbled because I have sat 2 desks away from Matthew over here. Truly a master chef. All of you know people out there who learn a craft. You hope one day someone can learn the craft more than you and can kick your behind. That is Matthew. Matthew, I hand over to you the AI Chef apron officially to continue with your cooking.
Thank you. I'm actually kind of shocked. I knew this was going to happen, and I actually feel kind of emotional. So thank you, John. Thank you. So yeah, let's do some cooking. So I'm going to open up my computer here, and we're going to switch. So theoretically, y'all should now, y'all can see my screen. So like any great cooking demonstration, we are going to take a look at the ingredients. So I am pretending to be an AI researcher, so I'm coding in Python. Don't worry, we'll get to .NET and Java in a bit. Here we have our kernel, our toaster. We can add in our different services. We're going to be adding in plugins in a bit. And this is kind of the secret sauce. This is where we send in requests to, oh no, you're actually seeing the final stuff. Go away, go away. So this is where the magic happens, where we actually send requests to the AI and have it do things, right? Everything else on this screen is just loading chats from MongoDB, saving it, and powering my UI. Which, speaking of which, let's go ahead and just do a quick hello. You've seen this 1,000 times. Nothing special right here. Now you'll notice on the stage, I have a lot of props. I have a bunch of lights, and what I'm going to do is actually throw a party on stage in celebration of our V1 of Python and Java. Now to help, I want the AI to turn on the lamp. Now, as many of you know, the LLMs are just LLMs. They don't have capability, so it's going to say, I don't know what to do. And this is where plugins come in. So that code that you shouldn't have seen, but you did, so you got a sneak peek, is just that. So this is what it's like to load in a plugin. There's many different ways of loading in plugins, but this is the way for grabbing an open API spec. And this is my favorite way, because this is, I don't know about y'all, but this is what I'm familiar with. As an app dev, this is the way to document enterprise APIs. And here I have my light API. I can retrieve lights. I can change lights. It's everything my AI needs to know. And just like humans, why we create this is so that humans can understand how to use the APIs. Exact same way for the agents. We know the description, what it does. We know what the inputs are. We know what the outputs are. And we take all of that information in these few lines of code and give it to the AI. And so now, when we ask it to turn on the lamp, if we pray to the demo gods, it's on, it's on. So I want to have it turn on the rest of the lights. Y'all are going to have to tell me if these things actually work. I can actually see. OK, there we go, there we go. Great. But no party is great with very harsh white lights. We need to set the mood. And so this is where I want to introduce RAG and how we think about it within Semantic Kernel. So RAG is obviously retrieval augmented generation. You have to retrieve information in order to improve the response of the AI. In this case, we need to retrieve some really lovely colors so we can set the mood. So for that, again, I'm pretending I'm an AI researcher. I have built another, I'm just going to delete some stuff, another API. This is a Flask app. I have a scene. And what it does is it's going to generate an image with generative AI. It takes in a prompt, and it creates it. And then I have an image generated for me where I can grab colors. Right? Because this is an API that was built by a Python dev, I can go to its own OpenAPI UI, and I can even test it out. So I'm going to just, you can see the inputs here. I'm asking it to generate some colors based on the theme of Microsoft Build, how fitting. And so I can go ahead and execute this. It's going to think a bit. And what I hope you notice is it's kind of slow, right? Because we're asking this thing to generate an image just to give us some colors. And if we ran this at scale, that's not good, right? All we did is spend all that wonderful time just to generate, and I purposely used a bad model. This! Oh no, can y'all see it? Y'all can't see it. Has the feed? OK. So for some reason, y'all can't see that picture, which I guess is fine. OK. Have you, Lordy, OK. We will keep going. So there was a really bad picture, but it had the colors that I need, and that's all that matters. Now to improve the actual speed of things, this is where the concept of vector DBs comes into play. How many of you have heard of vector DBs and actually used them? OK, great. We're going to be using this to store this information to make it faster to retrieve these images, just like how you use it to retrieve information from your documents and use it to populate the context of the AI. So what I'm going to do here is I'm going to go ahead and add those bits back. At the top here, I'm generating an embedding, which is this like way of kind of understanding how semantically similar something is, and then trying to find a match. It's kind of like a cache. And then at the end here, we are actually saving whatever the images are. And so if we come back to our service and we run the scene one more time, oh, so you are able to see my screen now. Ooh, thank you. Instantly. Instantly comes back. So that's great. And since y'all missed it last time, I think it's just this one page like kills it. So we are not going to look at that image. The image is cursed. It's a cursed image, y'all. OK, so, you know, if that's the worst thing that happens during an AI demo, I will be happy. OK, so I can do it. OK, one thing to note is as an AI dev, I'm probably wanting to use things locally. I want to develop fast. So I am using 𝗦𝗲𝗃. 𝗦𝗃 has this really great capability of actually allowing you to create a Docker container for 𝗦𝗃 so you can get it spun up locally. And that makes sense, right? But once you pass it over to your enterprise devs, that's when you would either use the 𝗦𝗃 service or Azure OpenAI Search, right? Or Azure AI Search. So we've set up all this stuff. We can go ahead and come back and load in some additional plugins. Obviously, we now need to add this plugin that will retrieve the scene. And I'm going to go ahead and add a speaker plugin, because we also want some music, right? So I'm now going to ask it, please play .python.wave, but first set the mood with the lights. Okay, so we're going to send this over. And we're going to give it a bit. This is using the kind of native planning capabilities of the model. It's using automatic function calling under the hood. And what it's doing is it's first asking for, hey, what color should I use for the mood? In this case, it's kind of like, hopefully it comes back with colors that are for Python. And then it's going to play the music. It changed the lights. Great. And it should be playing a song. I don't hear it, so maybe the audio is busted. But it does say it's succeeded. I know for a fact that if it didn't fail, it would clearly tell me. The AI is really good at letting me know that it did not do a good job. So we're having some fun AV equipment issues. But that is OK. That is OK. That is OK. Alrighty, so that's Python. And now what we want to do is actually move it into some of our other enterprise applications, like Java. So I'm going to pull open what Java looks like. OK. And it should start to be similar, right? We have the same ingredients. We have the kernel. We have our plugins. We have our services. And I guess when I first proposed this talk, I was like, oh, I'm going to like literally copy and paste files. But where I imagine the future actually moving is instead, you have like either monorepos or you use like Git actions to like create these pipelines that aren't ML ops and DevOps, but a combined ops where all these things are combined. And here you can see I have this folder for plugin resources that all of my devs, whether they're Python, .NET, or Java, can use. And again, that reinforces, as an AI dev, I can make these changes, push them up to Git, and then everyone else on my team can use it in their respective language. That's really, really powerful. Okay? So I love to get to .NET, but we're going to take a pause and actually hear from one of our partners and see how they are using Semantic Kernel. So without further ado, I would like to invite Hiro Kobashi from Fujitsu to speak about composite AI.
Thank you very much. Thank you very much, Matthew, having me here, and good evening, everyone. It's a very great pleasure to talk about our collaboration between Fujitsu and Microsoft. Just in case you are not familiar with the Fujitsu, Fujitsu is one of the largest ICT company in the world, and we are the #1 in the Japan market. And our main business is B2B, and we are providing the many kinds of ICT services to the customers. And actually, in these days, the trend of customer requirements is about AI. Yes, of course. And especially after the advent of the generative AIs, the demand is getting higher and higher. So therefore, the issue is to how can I streamline the AI delivery to the customers. So that is the reason why we have recently developed the Fujitsu 𝗦𝗲𝗀𝗀𝗀𝗀 platform, which is make the AI delivery efficient from the research development to the product. And actually, we are providing the many kinds of technology through this platform already. That is good. However, there are two issues in front of the 𝗦𝗲𝗀𝗀𝗀𝗀 recently. So one is the number of the AI technologies. As you know, every single day, we are meeting the new AI technologies. So therefore, even we get a customer request for AI, it's very difficult to identify which AI technology is good for the customers. So how can I solve the issues? Is the one issues for us. Second issue is about the diversity of the customer request. So as I said, Fujitsu is a big B2B company. Means that our customer is spread out multiple business domains. So even we create a good AI system for one customer, but that system doesn't work for the others. So somehow we need to solve these issues for our AI solutions. So that's the reason why we are collaborating with the Semantic Kernel, and we have developed a new AI system that's called composite AIs. The composite AI is the systems that understand the business challenge via chat, in a natural language. And this automatically suggests solutions using the best AI model and data. As you can see in the right-hand side, that is the very simple architecture diagram of the composite AIs. It consists of 3 parts. One is the main part of composite AI, and one is the model lake, one is the data lake. As you can imagine from the word, model lake and data lake are stores, and model lake stores AI technologies, data lake stores data. And by utilizing these AI technology and data, we will create a very nice solutions on top of composite AIs. So, and I want to give you the more detail how we utilizing the semantic kernel by utilizing this slide. And as you can see, in the left, there is the users. And the user give composite AI the request. And the request go through the planner, which is implemented by the semantic kernel functionalities, actually, of course. And once we ask the planner, we can get the plan. And the plan will be passed the composition part and try to create the AI solutions. And in this case, the plan, I assume, the plan consists of three parts, three subtasks. One is the AutoML, which is the traditional machine learning technologies. And second step is for the optimization, and we call it as OptoAI. And third step is the visualizations. So by combining the modules, we can provide good solutions. And of course, these subtasks will be assigned to the task agent, which is implemented by semantic kernel again. And the task agent are connected to the model lake and data lake. And once all the result has been produced, the result will converge into one and pass back to the users. So this is a very simple sequence, but this is pretty much everything which I am doing in the composite AIs.
And I love this because you're combining these new LLMs with these traditional models.
Right.
Because they're not perfect at everything, right? But you're able to confuse them together with composite AI. You're using semantic kernel planners to decide which traditional model to use.
That's right. Yeah.
To get the final answer.
Yes, it's everything based on the customer request. Customer
Perfect.
give us a context, and we will decide which one is best for to utilize. Perfect. And that one is very good. Actually, no one knows how to use the AutoML or OptoAI, but semantic kernel will help us. To proceed. And actually, the most important thing today I want to say is that the composite AI is not a concept. It's a functional realities. So I mean, I brought two use cases. These are two real use cases. And I would like to show you the demo video later, but let me explain about the use case detail first. So first use case is about Nakayama Transport, which is a logistics company in Japan. And the logistics companies in Japan are facing the one issue, so-called Logistic 2024 issue. And this means that in the last April, the new law has been introduced in Japan, and there are so many complex rules are introduced to logistic companies. So they need to follow the rules. But if they want to create efficient driver assignment planning, it is very difficult to create by manual. So that's the reason why they come to us. And we utilize the composite AI to create a plan, and they utilize the plans for their purpose. So this is the one. Second use case is about my case, I mean our use case. Fujitsu is utilizing the composite AI, of course, in our business. As I said, Fujitsu is a big B2B company, and we have a service desk service in our capabilities. And in the service desk, we are getting the many incidents from customers, and we need to carefully think which incident must be assigned which agent. Otherwise, we may violate the SLA, then we need to pay a penalty to the customers. So such kind of thing, composite AI suggests us to create a very nice solutions, and that is the composition of the prediction and optimizations. Means in the prediction, we did a incident completion prediction. I mean, then we can get the time of how long does it take for each incident, and based on the result, we will optimize the assignment of the incident. So
demo time?
Yep.
Yeah.
Let's go to demo them. So this is the let's say start page of the composite AI, and as I said, so there are the two use cases in here. Yeah, it's started.
Okay, great.
Okay, there's the two data source in the data lake, and there's the 34 AI technologies in the model lake now. So, and these, the 34 technologies are stored in Kozuchi, which is another AI system in Fujitsu. So, composite AI will utilize these technology for based on the request. So let's get inside the Nakayama Transport first. So this use case is already done. So let's say this is the kind of completion pages already. So and you can see the overview in here, task division here, and the constraint here, and they were utilized for the context to create the plannings for the optimizations. And this is the result which we got from the composite AI of the AIs. And the vertical means the tracks, and track has the each boxes, and the boxes this means that driving sections. So the one truck is going to the several sections in here. This is well aligned for the schedulings. So the Nakayama transport can utilize the plans for their purpose. Fujitsu use case, this one, as you can see, it's not started yet. Just there's a little context in here, so therefore I want to put more context to the composite AI now. So and through the chat, so you can give him the more context of what you want to do. And based on the input, compositor will understand what can I do. However, sometimes composite AI needs more context. So then he replied back to us, and I give more context of what I want to do again. So in this case, I give some agent characteristic and some constraint of the jobs, and then composite AI understand what should I do. And once he understands, he starts the planning, something like this. So this is a planning produced in a JSON file format. And of course, you can see it in the dashboard. So this pipeline is quite simple. It loads data from data lake, pass it to the AutoML, and please optimize by utilizing digital annealers.
And I love this because you're basically making planners your own. You have a UI on top of it.
Yeah.
And I guess what you're seeing right now is you can edit it, right?
Yeah, that's right. Changing the module. So if you don't want to utilize a digital annealer, you can change it to the other one. And the other one is something like OptoAIs. It's very easy. It's very quick to do that. And once everything they completed, so just say yes, and then the process will go on. So I mean, the process is going to planner, task agent, and we'll try to execute everything. And once everything happens, so in this case, data is loaded from ServiceNow, and it's passed to the AutoML, and the OptoAI will did the optimization for us. So this is everything, pretty much everything. And of course, we can dig inside like this one. So AutoML part. So this one is these code are synthesized by the generative AI.
So repeat that, like the AI wrote this code, executed it, so no human is trying to figure out how to use these traditional AI models. The AI is doing it.
AI did it. And also it's going back, but we did a formalization. So in our optimizations, we need a formalization beforehand. But that one is quite difficult for non-expert. But in this case, it's Gen AI. So our composite AI can do it for you automatically. And the most important thing I want to show in here is will be appeared in the right-hand side. Go down a little bit. So OptoAI, as you can see, there are some status here, and it's finished successfully. But you can see some errors in here. But these error is automatically revised inside of the composite AI. This is a very nice, actually, the good functionalities in here. And once everything has been done, we can get this kind of result.
That is great.
Yes, and this is the assignment of the agent for each incident. So the top is the aligned means, so we can finish in the same times for these 5 agents. Right, this is everything I want to show you here. And also, one more.
Oh, yeah.
We have published the Microsoft blog yesterday. If you are interested in the semantic kernel collaboration with composite AI, please check it out. We have the white paper of the composite AI.
Well, thank you. Before you go, though, we did have, since you're, yes.
Plugins, planners, and personas, and so you are now truly an AI chef.
Yeah, well, thank you very much.
Thank you.
Yeah,
thank you.
Thank you.
So let's go back, and as I promised, we'll quickly do a .NET demo. And what I want to show off is actually really inspired by what Hiro just demoed for us. So at the very end, he showed how the AI was able to write Python in order to complete some fairly complicated tasks, right? And so what I have done is I have spent some time talking back and forth with my AI yesterday. Let's just see. OK. So what we can see here is me having a back and forth conversation with the AI and how it can help me with this particular demo. And what I wanted to do is actually have it synchronize the lights to the music. Now, because audio is not working, we're just going to skip that part of the demo. But what I really want to highlight is how the AI is able to use Python. And one thing that we've learned from customers like Fujitsu and other projects like TaskWeaver is the best way to have the AI create and execute plans is with Python. And so as we scroll through this chat, we can actually see how the AI is able to use things like traditional models like 𝗦𝗲𝗀𝗀𝗀, how it can use my plugins like my lights down below. And as it runs into issues, yeah, sometimes I kind of course correct it every so often, but it's typically smart enough in order to actually fix those problems itself. Now, traditionally, Semantic Kernel has kind of shied away from using Python as that language to do that planning capability. But I am proud that Microsoft in the last week has shipped as part of Azure App Containers, Azure Container Apps, a new feature called Dynamic Sessions. How many of you know what code interpreter is? Okay, so we have a few people. So in Systems API, the AI can actually write and execute code. What's special about Dynamic Sessions is it's the technology that powers all of that. Right? That's cool, right? And they have now released it as a service that all of you can now use. And so all of this code that was run and executed and tested by the AI was actually done by that service. And it's something now that you can use. It's fully locked down. It can't make HTTP requests unless you want to. But what's powerful with Semantic Kernel is you can make it talk to your plugins so that you can do things like change the lights. Okay? So with that, we're going to, actually, one last thing. If we did see the demo working, I'm not going to risk it because clearly there's like very evil spirits in this room. If we were doing this, there is a risk. I could have the lights actually strobe and give someone a seizure. That's not good, right? And so one of the pieces that's important as part of responsible AI is actually having control over what the AI ever does in the real world. And so what we've been recently introducing to Semantic Kernel is this concept of hooks or filters. And this is key to enterprise production deployments, right? This is hard to do in many other SDKs because they don't think about these things, right? Every time the AI tries to invoke a function, every single time, this filter will be called. And you can see I have this nice little case. If the function that's called is change light state, I can actually do a detection to see, like, is this too fast? Am I strobing? Am I doing something dangerous? And I can stop it, right? And if you kind of think about enterprise scenarios, let's just take a step back. You have your Swagger APIs that you can use. That's something that you already have. And in terms of safety, you can use these filters to make sure that the AI isn't doing something inappropriate, like spending too much money or sending an email when it's not supposed to. You can loop in a human. This is powerful. This is basic 101 stuff if you want to ship a safe AI application. And I think that's kind of a motive that we're hearing here. Hooks, safe. Python dynamic session containers. It's kind of the safest way you can do things, right? Using your APIs. This is the enterprise story that Semantic Kernel is trying to provide you. So with that, we're going to round things off with one last customer. We're going to be inviting Accenture to the stage. But before, they had a quick video that they wanted to play for us. I want to go ahead and play it, and hopefully the audio works. Are we having any audio? No. So in that case, I'm going to go ahead and pause this. We're going to invite Accenture to the stage. Please help me welcome Adam and Dan to the stage. Thank you, thank you. So Adam, you're the Chief AI and Data Architect for all of Accenture. Dan, you're a director. It's great to have you. You are using Semantic Kernel. Can you tell me about it since our video unfortunately did not work?
Yeah, absolutely. So I lead up our strategy and architecture for Accenture Global IT. So what we do internally, how we run the Accenture business. And a lot of times what we try and do is become the first best credential for then what we can go deliver to our clients. And so our flagship Gen AI product right now internally is called Amethyst. And we're using Semantic Kernel at that orchestration planner level to really build out an AI assistant. Accenture is a very large company, about 750,000 people, a lot of different groups, a lot of different organizations. You can imagine navigating a company that large can become very cumbersome, challenging. Trying to identify the human to be your RAG is very, very difficult. So, you know, we're able to use Semantic Kernel and Gen AI to develop that RAG. And we have quite a few plugins to be able to go and get quick tasks done. So the video that we were going to show, you know, if you need to go identify your PTO time, if you need to go identify what case studies or clients have we done work on in specific industries or areas, or who are the experts we need to go identify. We're able to really build up this dynamic set of requests and responses and plans with a lot of using and leveraging a lot of our existing APIs throughout the enterprise.
That's great. So Accenture is a big place. You'll have a lot of different development teams. I'm assuming folks use Python, Java, .NET. Is that right? Like, what's the AI development story across all these very different teams?
Yeah, for sure. I think like a lot of other companies, we've had our ups and downs in trying to figure out what's the right balance between data scientists and our AI researchers and our app developers, right? So my group spends a lot of time building automated templates and, you know, kind of CI/CD tools and you know, gated pipelines, right, that just don't let bad code into production, right? And you know, often there's a lot of friction between my team and our AI researchers who are very used to things like notebooks and workspaces and, you know, running a little Python script and they produce some really wonderful stuff. And then they get really upset with me when I say, that didn't pass a security scan, you can't release it to production.
Yeah. And it's developing that culture, right? And making the two types of developers kind of understand each other.
No, so I mean, you know, for us, something like Semantic Kernel being available in multiple languages, so things that are, you know, AI researchers like working in, like Python, right, is their number one. And, you know, the same exact code or the same exact features being available in something like C#, right, which I much prefer in terms of, you know, just in terms of scale and efficiency and energy usage, right? I can spin it up quickly. I can run it in the serverless thing, you know, serverless mode. You know, so that's way better from my perspective to get it into that. So what we ended up relying on a lot of times was really having a very small set of developers that kind of knew both and could put a foot in each world and do that translation before from, you know, Python methods to something that, you know, is more like, you know, C#, you know, a traditional web API. And, you know, with Semantic Kernel releasing on both sides, that's a much more natural fit. We don't have to do transpilers. Or
it's one less thing for folks have to learn to create that trusted culture, right? Take away the technology bit, and now it's about processes. So maybe one last question. You'll have customers too. They probably use a bunch of different languages and have different processes. Can you tell me more about like how Accenture is helping customers work with AI?
Yeah, absolutely. As I mentioned before, a lot of times we go out and we're that first best credential for our clients. So a lot of the work we're doing here is turning into assets that we can then go deliver on. And the beauty of Semantic Kernel is its ability to span all the different needs of, you know, our diverse clients. You know, internally we do a lot of .NET. A lot of our clients do Java, and the vast majority, right, of the AI work happening is happening inside of Python. And so I think we're able to accommodate a lot of that. And as you all know, when you get into these enterprises and these IT shops, there's a lot of existing processes already designed for things like .NET and Java. And so being able to have the patterns and the assets to start treating these plugins and these services and these agents as just microservices that can adapt and leverage all the existing operational tooling and performance and security that already exists is a huge win for us and for our clients.
Perfect. Well, thank you for joining us at Build. A big round of applause for Dan and Adam.
Dan and Adam said plugins. Please, the AI apron is for you.
Well, and I love the Accenture story because y'all are able.
One second.
No, yes. Thank you. Because y'all are able to build assets over time that can work across all of your customers no matter what language they're using. So thank you. We have a few minutes left, so I'm going to be inviting Evan, my boss, back. Thank you. To talk about how you can join our community, how you can become a master chef yourself. So Evan, take it away.
Awesome. Thank you, Matthew. All right. Unfortunately, we'll try this and see. We had an amazing community video. So we'll post it online on our blog. You have to check it out. A lot of people responded to our call to tell you about what's going on with Semantic Kernel. So you can check out our blog. You can see the whole thing. We'll post the long video. Thank you to the community for doing this. This is really amazing to hear these stories. For you, right, it's awesome to hear directly from customers. It's awesome to hear from the community and to see what they're creating with AI. Now's your turn, right? You can be an AI chef. We want to see what you create. It's never too late to start that AI journey. Start today, get involved, join the community, and we can't wait to see what you're doing and showcase that on stage, again, a year from now, next year, to have you on the videos, to have you on stage talking about your AI journey. So thank you again, and thanks for coming.